Every year, 14,000 ships pass through the Panama Canal. It is the most important, heavily engineered waterway on Earth. You were likely taught that carving this path between the oceans was a triumph of early 20th century politics and medical science, a romantic narrative of eradicating yellow fever and taming the jungle. But at the Titanmetrics audit desk, we do not evaluate politics. We audit structural physics. And the brutal, raw physics of how this canal was actually built do not compute. A single steel lock gate on the Panama Canal weighs 730 tons, or 662 metric tons. To open and close this colossal, wet steel wall against the friction of an ocean in under 2 minutes, the official ledger claims they used a 40-horsepower electric motor. A modern riding lawnmower generates 25 horsepower. How does an engine the size of a lawnmower swing 700 tons of steel? It is a mathematical impossibility, unless you audit the hidden hydrostatics. Welcome to the forensic audit of the Panama megastructure. Forget the mosquitoes. We are going to audit the kinetic bottleneck, the exothermic concrete paradox, and the brutal mathematics of the continental fracture. Let us open the ledger.
To connect the Atlantic and the Pacific, engineers had to carve a 9-mile canyon directly through the jagged spine of the continental divide. Welcome to the Culebra Cut, the absolute epicenter of the logistical anomaly. The official narrative glosses over this excavation as a simple matter of digging. They show you staged archival pictures of 95-ton Bucyrus steam shovels chewing through the rock and expect you to be satisfied. But digging is not the problem. Digging is a static action. The true engineering nightmare is displacement. Where do you put 200 million cubic yards, or 152 million cubic meters, of crushed rock and wet clay? You cannot pile it next to the trench. The sheer crushing deadweight of the excavated earth would trigger catastrophic landslides, violently collapsing the canyon walls back onto the workers. Every single ounce of that dirt had to be physically transported miles away from the excavation zone. The Panama Canal was not a digging project. It was the most complex, high-velocity railway logistics matrix ever conceived. At its peak, a fully loaded dirt train exited the Culebra Cut every 3 minutes. That is 200 heavy freight trains a day. But let us audit the track logistics. As the steam shovels dug deeper and wider, the track trains had to follow them. This meant that miles of heavy steel rails and wooden ties had to be physically picked up and moved sideways across the mud. Every single night. This was not done by machines. This massive lateral track shifting was executed entirely by human biological engines. Thousands of exhausted laborers using crowbars and brute force to pry frozen steel rails out of the tropical sludge, operating in the pitch black of the jungle night. The caloric deficit and kinetic toll of this manual track shifting should have paralyzed the workforce within weeks, yet the official timeline insists the trains never stopped running.
But let us audit the math of the dirt trains. A standard dirt train consisted of 20 flat cars carrying 400 tons of wet, dense spoil. When that train arrived at the dumping ground, how did they unload it? If you use manual human labor, men with shovels, it would take an entire day to clear one train. The kinetic bottleneck would choke the project to death in 48 hours. Enter the Lidger Ward unloader, a masterpiece of brute force analog engineering. They did not use shovels. They took a massive 3-ton steel plow, placed it at the back of the train, and attached it to a heavy-duty steel cable spanning the entire length of the train. A heavy steam winch at the front of the train would violently reel the cable in, dragging the steel plow forward across all 20 flat cars simultaneously. In 10 minutes, a single mechanical motion violently swept 400 tons of rock into the abyss. But the official history ignores the friction. Dragging a 3-ton steel blade through wet clay and jagged rock tore the wooden flat cars to pieces. It required a massive, hidden infrastructure of repair shops working 24 hours a day just to replace the shattered wood and bent steel. It was not a clean administrative task. It was a continuous, violent war against mass and gravity. And before you can load the rock, you must shatter the mountain. Let us audit the chemistry. To fracture the Culebra Cut, contractors utilized 60 million pounds, or 27 million kilograms of dynamite. Dynamite in 1910 was highly unstable. It required careful temperature control. In the sweltering 95-degree heat of the Panamanian jungle, the nitroglycerin would sweat out of the dynamite sticks, becoming lethally volatile. Transporting 60 million pounds of sweating, impact-sensitive explosives on rattling, unsprung wooden train cars over uneven mud tracks is a statistical death wish. The premature detonation risk was astronomical, yet we are asked to believe this staggering volume of volatile chemistry was managed with near-perfect logistical safety by an unmechanized workforce. It is a logistical phantom.
Removing the earth was only phase 1. Phase 2 requires us to audit the concrete. To lift the hypermassive ocean liners of the era 85 feet above sea level, the engineers had to construct the largest concrete structures ever built by humanity up to that point: the Gatun, Pedro Miguel, and Miraflores locks. We are talking about 4.5 million cubic yards of concrete, walls that are 81 feet thick at the base. Mainstream history presents this as a simple pouring operation. You mix cement, sand, and water. You pour it into a wooden form, and it hardens. This is a fatal misunderstanding of chemical thermodynamics. When Portland cement mixes with water, it triggers an exothermic chemical reaction called the heat of hydration. It literally generates fire from within. When you pour concrete for a sidewalk, the heat dissipates into the air. But when you pour a monolithic concrete wall 80 feet thick, the heat in the core has nowhere to go. If they had poured the Gatun locks continuously, the internal temperature of the concrete would have exceeded 200 degrees Fahrenheit, or 93 degrees Celsius. The water inside the mixture would have boiled into steam, expanding violently and shattering the massive locks from the inside out before a single ship ever entered the chamber. Decades later, when building the Hoover Dam, engineers solved this exact paradox by embedding hundreds of miles of steel pipes and pumping liquid ammonia through the concrete to artificially freeze it. But the Panama Canal was built in 1910 in a tropical jungle with ambient temperatures of 95 degrees and 100% humidity. They did not have liquid ammonia cooling systems. So how did a primitive, analog workforce pour a 10 million-ton concrete monolith without it fracturing into dust? The corporate ledger reveals a brutal, labor-intensive workaround. First, they abandoned the idea of a continuous pour. They built the locks in isolated, modular blocks, allowing each section to bleed off its kinetic heat before pouring the next. Second, they weaponized the jungle's own geology. They excavated massive solid volcanic boulders, some weighing up to 5 tons, and dropped them directly into the liquid concrete from giant aerial cableways. These plums, as they were called, acted as massive thermal heat sinks. The cold, dense rock absorbed the exothermic heat of the curing cement, stabilizing the chemical reaction. It was not an elegant solution. It was a desperate, high-risk thermodynamic gamble.
If the mixing ratios were off by even 2%, the entire structure would have collapsed under the hydrostatic pressure of the artificial lake it was designed to hold back.
Which brings us to the most glaring mechanical anomaly in the entire global ledger, the gates. A lock is useless if it cannot hold water. The gates of Gatun are 80 feet high, 65 feet wide, and 7 feet thick. Each steel leaf weighs approximately 730 tons. Let us run the kinetic physics of the hinges. If you attempt to hang a 700-ton solid steel door on a traditional hinge, the kinetic shear force will instantly snap the steel pins. The door will rip itself off the wall under its own dead weight. Furthermore, to operate the canal efficiently, these massive gates had to be opened and closed in under 2 minutes against the resistance of the water. Mainstream history will tell you that the gates were powered by electric motors. What they conveniently omit is the size of those motors. The motors that swing these colossal 700-ton steel behemoths are only 40 horsepower. I want you to process that number. A modern riding lawnmower has 25 horsepower. The official narrative expects us to believe that an engine slightly more powerful than a lawnmower was capable of swinging 700 tons of wet steel. It is a mechanical impossibility, unless you audit the internal schematics. The engineers at Harland and Wolff who built the Titanic failed to understand the limits of their materials. But the corporate engineers of the Panama Canal executed a masterstroke of hydrostatic physics. They did not build heavy steel doors. They built submarines. The bottom half of every single lock gate is completely hollow and hermetically sealed to create a massive air chamber. The top half is designed with open compartments that flood with water. When the lock chamber fills, the massive steel gate does not hang on its hinges, it floats. The buoyancy of the trapped air pushes upward with hundreds of tons of force, perfectly neutralizing the downward pull of gravity. In a dry dock, the gate weighs 730 tons, but suspended in the water, perfectly balanced in hydrostatic equilibrium, its effective operational weight is reduced to almost nothing. The hinges do not bear the load, they merely guide the rotation. That is why a 40-horsepower motor can push a steel leviathan. It is not moving a wall of iron, it is moving a perfectly calibrated, floating anomaly. If you are tracking these engineering paradoxes with us, hit the like button to bypass the algorithm suppression. Now let us look at the true cost of the canal.
Machines do not build megastructures alone. Steam shovels require coal, locomotives require water. And the manual displacement of the track networks required the most inefficient, fragile engine of all, the human body. The historical ledger romanticizes the labor force. It speaks of unity and perseverance. Let us speak of biology. Let us audit the caloric burn. Tens of thousands of laborers, primarily imported from the West Indies, were deployed into a literal furnace. Swinging a 10-pound sledgehammer or carrying heavy railroad ties in 95-degree heat with nearly 100% humidity pushes the human cardiovascular system to its absolute kinetic limits. The average biological unit in the Culebra Cut was burning upwards of 6,000 calories a day. If you do not replace those calories, the human engine begins to consume its own muscle tissue. The mechanical output of the workforce drops, the kinetic conveyor belt slows down, and the continental fracture fails. The canal administration quickly realized they were not managing a construction project, they were managing a massive biological refueling operation. They had to import highly dense, cheap caloric fuel by the thousands of tons, creating an entire shadow logistics network just to keep the human engines from seizing up. When mainstream history tells you how many died from disease, they deliberately obfuscate how many bodies simply broke down from mechanical exhaustion, their biological limits shattered by the impossible demands of the schedule. The Panama Canal is not a monument to politics. It is a monument to brute force, kinetic violence, and thermodynamic survival. It is a structure built on the absolute bleeding edge of analog technology, saved from total collapse only by embedding volcanic boulders into boiling concrete and turning 700-ton weights into submarines.
The official historical record wants you to look at the water and marvel at the journey. But at the Titanmetrics audit desk, we look at the mud, the friction, and the hydrostatic pressure. We read the numbers they tried to hide. The Panama Canal survived because its engineers weaponized physics to cheat nature. But what happens when corporate arrogance ignores those exact same laws of physics? What happens when the engineers who built the Titanic completely misunderstand the thermal limits of their own steel? The Titanic wasn't sunk by an iceberg, it was a thermodynamic failure. That file is on your screen right now. The ledger remains open.